Hi, I'm Andrew Freed from IBM's Watson Group, and I'd like to talk with you about developing natural language processing using rules. Rules-based natural language processing uses a programmer who detects and extracts patterns from a given block of text. Let's give it a shot. Since I am a programmer, the first thing I thought of was to extract programming languages from the Wikipedia article on programming languages. Now, like I said, we need to extract patterns from this text. So there's a couple things I know. The first thing I know is that most programming languages are going to show up as proper nouns. On the first page here, we can see the C programming language and the Perl programming language, both of which starting with capital letters. So my first suggestion is going to be, let's start with looking for words that have capital letters. As I read through this article, looking for additional clues, I don't just want to extract all the words with capital letters. That's going to be way too many words. But as I scroll through this article, I see a lot of lines like here's XML and HTML. I know their languages. I see a few other languages here. And I see that oftentimes the word language itself shows up in the same sentence as these languages I'm going after. So I'm going to start building a very simple rule. I'm going to look for sentences that contain the word language, and I'm going to take all the capitalized words out of those sentences and declare that they're programming languages. Because I'm pretty sure the first letter of the first word in each sentence is probably not a programming language, but is capitalized because of proper English. I'll leave those words out. So let's look at the code. I've got a pretty simple program here that's going to implement this rule for me. I'm reading in a file, I'm splitting the file into sentences. At the start, I loop over each sentence and I look for sentences that contain the word language, like I said. I'm going to extract the words out of those sentences, and I'm going to look for capitalized words in those sentences. Now, this is a pretty simple program. It's not going to be a fantastic rule, but let's give it a shot. Let's see what it looks like. We can see I've got output pretty quickly here. I did write this program so that anytime a programming language was found, I'm going to print the language and the sentence that it came from. So let's look at some of these languages that were extracted. In this first sentence here, it tells me there's 4 programming languages: C, ISO, Standard, and Perl. That's not exactly right. C and Perl are definitely programming languages. ISO and Standard are not. As I scroll through this, I can see a couple of these are actually definitely correct. XML, HTML, those are languages. If I read down a little farther, AutoCode is a programming language. ML and Lisp are programming languages. So I can see that I'm pulling out a fair amount of good hits. These are correct hits. They're programming languages. But I also see that I'm pulling out a lot of things that are definitely not programming languages. In this sentence here, Dijkstra, he was a programmer. Communications, ACM, that's a magazine. GoTo is not a programming language. So what I see is I was able to build this rule fairly quickly, but we find out that it's only so-so. As a matter of fact, I tallied up the results from this little program, and I found that there was approximately 100 languages in that article that it should have found, and approximately 50 that it did find. There was 50 languages that it missed, and 50 words that it said were languages but were actually not. So in terms of accuracy, this model is about 50% accurate. We can see that's not bad for a first pass, but ultimately it's not going to get the job done. But I'm going to save how to improve this model for a future video.